So, from these days, although we don't know if they are actually periodic, we can assume so because the Earth rotates around the sun at the same rate every year. Being that December 21st is the winter solstice, we know that the winter solstice is the day of the year with the lowest number of daylight hours, so this is our minimum. And our maximum is June 21st, which is the summer solstice. So we know this going into our equation. Next, we are going to find the A, B, H, and K. So, to find the A, we are going to find the difference between the maximum and the minimum. So 15.27 minus 9.07 and divided by 2, which gives us 3.1. So 3.1 is our A value. Next, to find the period, we know that the period is equal to 365 days. So, and we know that B equals 2 pi over period. So we find that B is equal to 2 pi over 365. 2 pi over 365. We are going to skip the H value for now and move on to the K value. The K value is the midline and is simply the A value plus the minimum value, which becomes 9.07 plus 3.1 and gives us 12.17. Now, for our H value. We all know that to go from sine to cosine, it is a shift of 1/4 of your period. Therefore, we need to find a quarter of our period first. So, we are going to divide 365 by 4 and find that 365 divided by 4 is 91.25. Sadly, this problem isn't that simple. The 91.25 is when it starts at December 21st. But our equation must start, our 0 must be December 31st. So we need to shift 10 and go more positive 10. Shift 10 up to a more positive direction towards the maximum, which means we are going to be subtracting 10. So that means we subtract 10 from a quarter period. So 91.25 minus 10 gives us 81.25, and 81.25 is our H value. So our final equation is going to be f of t equals A 3.1 times 3.1 sine B 2 pi over 365 times t minus h 81.25 close brackets plus 12.17. And that is our equation for the daylight hours in Boston, Massachusetts.